Hey everybody, so here's going to be a video continuing our discussion on the family of parallelograms and looking at rhombuses, rectangles, and squares, okay? So all these belong to our quadrilateral family. So think of it kind of like a family tree. You get certain traits from your parents and your grandparents, and just that ancestry, those traits get passed down. So a quadrilateral is just any four-sided shape. And then if we narrow our view to a parallelogram, that's what unlocked all those previous properties like opposite sides, congruent, and parallel. We also had that opposite angles were congruent, and we also had that the consecutive interior angles were supplementary, and that the diagonals bisect each other. All of these were properties of a parallelogram. Okay, now the parallelogram has a couple kids. Parallelogram has a rhombus and a rectangle. Okay, the rhombus, a new trait for a rhombus is that it has four congruent sides. All the sides are going to be congruent in a rhombus, whereas in a rectangle, it has four congruent angles. Notice that all the angles, you know this, all the angles of a rectangle are 90 degrees. Now, at the very bottom of this family tree is the square. So it's taking all of the properties from the figures above it. So it's going to have four congruent sides and four congruent angles. Now, rhombus, rectangle, and squares, those are going to have other properties. We're going to talk about those later, okay? But here is just kind of how they are all a little bit different from each other. Parallelogram is just two opposite sides are parallel. Rhombus, those sides are all congruent. In a rectangle, all the angles are congruent. In a square, both the sides and the angles are all congruent, okay? So, for any rhombus RSTV, so I'm just going to sketch out a rhombus here, RSTV. Now all of these sides are congruent in a rhombus. We want to determine whether this statement is always or sometimes true. Okay, this first statement is angle S congruent to angle V. Well, angle S is right here. Angle V is right there. Now, notice that those angles are opposite of each other, okay? And from parallelograms, it's taking the property that opposite angles are congruent to each other. So this is always true. This is always true because opposite angles are congruent. It takes that property from a parallelogram. That's always going to be the case. Now, for the next one, angle T, get a different color here, angle T congruent to angle V. So we know that they're going to be supplementary to each other, but we don't necessarily know that they're congruent to each other. Okay, now could it be true? It could be true, so it's sometimes true. Now what would have to be the case is that this rhombus would actually have to be a square if RSTV is a square. Okay, so a square is technically a rhombus. A square is technically a rectangle. A square is technically a quadrilateral, right? But a rhombus isn't always going to be a square. Okay, so it's kind of like that old saying that a square is a rectangle, but a rectangle is not a square. Maybe you've heard that, maybe you haven't. It just means that a square takes that property from a rectangle, but a rectangle doesn't necessarily have all the properties of a square. Okay, so that's going to be sometimes true there. What about the next one? Let's just classify it based off of its most specific name. So we want to see what the figure tells us. Okay, in example A, we don't want to go off what it looks like, what it's telling us mathematically. So example A, we see that opposite sides are congruent, right? 20 goes with 20, 16 goes with 16. Is there anything else here? Do we know anything with the angles? Are we told anything else? The answer is no. So even though it looks like a rectangle, mathematically, the most specific that we can say here is a parallelogram. Okay. What about for the next one? What's it telling us? It's telling us we've got 4 congruent sides. So we've got 4 congruent sides. All right, and we've got one angle is 70. So we could fill in all the other angles. That opposite's going to be 70. The consecutive interior is going to be 110. So we've got 4 congruent sides. All the angles are not congruent, so the most specific we can get is a rhombus. Okay? So I told you earlier that there were going to be more properties with the rectangle and the rhombus. Let's get into what those are. So the diagonals of a rhombus. Excuse me. So a diagonals of a rhombus, a parallelogram, is a rectangle if and only if its diagonals are perpendicular. So notice right here, those diagonals are perpendicular to each other. So what we can create here are 4 right triangles. Well, what do right triangles unlock for us to be able to use? We could use Pythagorean theorem. We could also use our favorite thing, trig, right? We could use SOHCAHTOA if we've got a right triangle. So we've got 4 right triangles that we can unlock because the diagonals are perpendicular to each other. Not only do they cut each other in half, remember your diagonals bisect each other, it takes that trait from your parallelograms. All right, they are also perpendicular to each other. That's a new thing that is specific to a rhombus. All right, another thing that's specific to a rhombus is that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So not only do they bisect each other, the diagonals bisect each other, now those are also bisecting their opposite angles. So if you notice that with the diagram here, you see the one swoop and the one swoop showing that angle A is split in half. Angle D is split in half. Angle C is split in half. Angle B is split in half. Okay? So the diagonals bisect each other. They're perpendicular to each other. And they bisect the opposite angles. So that's specifically with a rhombus. Now, for a rectangle, a parallelogram is a rectangle if and only if its diagonals are congruent. Okay, so its diagonals are congruent there. That we haven't seen that before, right? Remember, a parallelogram was shifted, so there was always a longer diagonal. But with a rectangle, your diagonals are going to be congruent to each other. Now, remember that at the very end of this family tree was a square, and the square took all the traits from those figures above it. So all of these specifics with the diagonals, those are also for a square. Okay? So that square is taking all of those properties. So in the next couple videos, we're going to go over some specific examples and how we can apply these properties to previous things that we've learned, previous concepts like trig, like Pythagorean theorem, like triangles, okay? So go ahead and tune into those next couple videos.